calculator is going to be a pretty good tool that we can use. It's going to allow us to do a lot of different things and be able to, like graphing especially. As we go through this, what I'll tell you is I don't have any issues with you using your calculator whatsoever. But as we do it, then like on a quiz or a test, we're going to need to be able to take that from a calculator onto like a graph. And so we got to be really specific about points that are on the graph. Like, does it have an x-intercept, a y-intercept? Where are those points at? So we got to be specific about where we graph. We can't just slap a line up there and say, here's my line. And you can do a lot of that things from your calculator, but we'll kind of talk about some other ways that we can get there as well. I'm going to put some graph paper up here to do some of these today. So I'm going to give you an equation. There's a lot of different types of equations that we're going to look at today. The first one here is good old slope-intercept form. And I'm going to tell you this today. They don't talk a lot about slope-intercept form yet today. They're just asking you to like graph some points and using the points to make a line. But because we've graphed this before and we know this is slope-intercept form and we've seen it before, and this is probably the easiest and quickest way to graph it, I'm going to show you how you can do it by hand. Obviously, you can put this into the calculator. Anytime you have an equation that's in y=4 form, we know that we can just put it right into the calculator. And so we'll talk about both. And if you have your calculator, you can go ahead and get it out if you want. But this number here is our slope, and this number here is our y-intercept. And going back to, and we've been graphing slope-intercept form since we've been in Algebra 1. We do it in Algebra 2. We even do it a little bit in geometry as well. We're going to plot the y-intercept first. And my y-intercept is at -4. So we're going to go down 4 on the y-axis, which is your vertical axis. Okay, second step is we're going to plot the slope from the y-intercept. So we have to have a point to start with. I can't start with slope because I don't have a point to begin with. But now that I have a point, my slope is 3/1. And we think of that as rise over run. And we'll talk more about slope as the chapter goes along, but I'm talking about it a little bit earlier today just because I'm familiar with this. I use a y when I spell rise here to keep me in mind that I'm going to move up and down. Y's go up and down, so my rise goes up and down. It's with my y value. And that just helps me to remember that I'm going to go up 3 first from this point, and I'm going to go over 1. And one of the nice things about using slope-intercept form and using my slope here is I can do that as many times as I want, right? I can go up 3 over 1 or down 3 and left 1 as many times as I want. It doesn't matter what direction I go. Okay, these points are going, and I can put an infinite number of points on here. I can keep going as long as I want to. Usually 2 or 3 points is probably sufficient, but in this case, I just kept going, and you could keep going if you wanted to. And then my final step, step 3, would just be connect your points and make your line. And that would be our graph. Okay. And I'm totally fine with you doing that. If I were to do this on my calculator, okay, and I'll just, so we could make a table of values, right? And it would just be like another step or another process of getting there. So there was a couple of points. Those points here were on this line, and we got it from doing this as well. But what this basically means is that this ordered pair or this ordered pair satisfy this equation. Because if I were to plug 1 in for x, 3 times 1 is 3, 3 minus 4 is negative 1. And so 1, negative 1 is this point right here. Okay, I could plug in 0, and I could get negative 4. And so I have a bunch of ordered pairs that I could come up with. And it's, once again, unlimited. It'll go on forever. You have a bunch of points that you could use to graph that. Okay, so just kind of knowing where the points tie into the graph and the slope and the y-intercept and all of that is still kind of good to understand how those all work together. If I have one like this, 3x plus y equals 6, there's a couple of different ways that you could do this one. A lot of people like using their calculator, okay? Well, in order to use your calculator, I can't put it in like this. In order to put it into your calculator, it always has to be in y equals format, right? Like the y equals mx plus b one that we just did. And so this one would be really simple to get into that form. So in this case, all I would have to do is subtract 3x from both sides. And I'm going to put it in the same format that the last one was. Y equals negative 3x plus 6. I always like to put the x in front. Remember that these cannot combine together because this has an x on it and this one does not. So that is my equation, slope-intercept form. So then what we wanted to be able to do is we want to graph this. And now graphing it is just like what we just did. Okay, you could put it into the calculator if you want to. You can do your slope and y-intercept. You have a lot of different options here that we could use to graph it. And we're going to go through the same process. This is my y-intercept. So we're going to go up 6 first. Our slope, in this case, is negative 3. And so when I have a negative slope, the graph's going to go down as it moves to the right. So my rise is negative 3. And we're going to go over 1. And we're just going to keep going. I could also go up 3 and left 1. The points move in opposite directions. Once again, because we solved it for y, we could put this one into slope-intercept form, put it into our calculator, and we could graph it. We got a lot of different ways that we can do it. And then we just connect the points together, and we got our line. Okay. But the points on the line are the biggest thing. It has to go through those specific points to be the exact line. We don't just want to take a line and say, oh, here's my line, right? Because there's a lot of different lines that we could draw on that. So it has to have those specific points in there to make it the correct line. Okay, so if I can get it into slope-intercept form, that's a good benefit, right? Maybe it's already in slope-intercept form, or if I can easily solve it for slope-intercept form, then life's pretty good. I can use my calculator pretty easily. If I give you one like this, this next one is what we call standard form. The generic form for standard form is ax plus by equals c. The a, the b, and the c value aren't going to represent anything. they're going to be numbers when I put it into my equation, but they don't have any meaning. They're not like the last one where it represents slope and y-intercept and other parts of my graph. And so slope-intercept form is a little bit easier to use. Standard form is a little bit harder to use if we keep it in this format. And so if I gave you an example here of standard form, if we have 2x minus 3y equals 12. I can't put this one right into my calculator like I did the last couple. Also, solving for y is doable, but I'd have to do a little bit of work to solve for y. I would have to subtract 2x, I'd have to divide by -3, and all of those things are okay. And I'll come back and do that here in just a second, just to kind of show you how they kind of are interchangeable. But I think the easiest way of graphing in this format is doing what I call the cover-up method. And when I do the cover-up method, we're finding two things. We're going to find the x-intercept, and we're going to find the y-intercept. We're going to find the two places it crosses the x-axis and the y-axis. So my x-intercept would be any point that falls on the x-axis. And if I think about all the points that fall on the x-axis, this would be 1, 0, 2, 0, 3, 0, 4, 0, as I move across the x-axis. All of those have a y value of 0. So I can put 0 in for y into my equation. And here's why I call it the cover-up method. Because if I take 0 and plug it in for y, 3 times 0 is 0, I'm just going to cover it up because it's 0, right? And so now what I have left is 2x equals 12. And I can solve that pretty easily. 2x equals 12, take 12 divided by 2, and that would give me x equals 6. And that should be a point that lies on the x-axis. When it's an x-intercept, it should be on the x-axis somewhere. For the y-intercept, it's going to lie somewhere on the y-axis. So we're going to put 0 in for x, because points on the y-axis would be 0, 1, 0, 2, 0, 3, 0, 4. We're moving up and down on the y-axis. So my x value is 0. So I'm going to plug 0 in here for x. 2 times 0 is 0, and once again, we call it the cover-up method because I'm just going to cover it up. Now don't cover up the negative in front of the 3 because that's attached to the 3. So I really have -3y equals 12. So then I'm going to take 12 divided by -3, and that would give me a -4. So signs are a really big deal here, okay? Positives and negatives, because is it up on the y-axis or is it down on the y-axis? So you got to really watch that positive, negative. And we did not find slope here, but when I make a line, all I need is 2 points, right? It goes back to geometry days, where if I wanted to make a line, I just need 2 points to make a line. And so here, I'm just going to connect these two together. And there would be my line. And that would be all you would have to do to graph that. If you showed me the x and y intercept, plot those two, connect them, and you got your line. And we haven't found the slope. Now, I told you I would show you this just so you can see this. If you really, really want to put this into your calculator and you want to solve it for y, you can do that. And some people like to do that because they like to be able to use a calculator, and I totally get that. It's just a little bit of work to solve for y. We want to get it in slope-intercept form rather than standard form. So we got to solve for y. And this would just be another method. Okay? You don't have to do this method. You can do the cover-up method, or you can solve for y. You got some options here. But to do that here, we got to subtract 2x. So I have -3y. Remember, you can't connect those together because 2 has an x on it. So I'm going to write it as -2x plus 12. But I still got to get y by itself, so I got to get rid of that -3. So we're going to divide by -3 all the way through. and that would be y equals. And then just be really careful of your signs here once again. We have a negative and a negative. So negative and a negative would make this a positive 2/3 x. And then 12 divided by negative 3 would be a minus 4. Okay, now just to show you the relationship that these have. Here my y-intercept is negative 4. Same y-intercept that we just had, right? We said it was negative 4 here, it's negative 4 here. Those two should match up. This time we found the slope instead of the x-intercept. So to get from here to here, I could go up 2 over 3. Up 2 over 3. Gives me the exact same line, right? And so that's why I'm telling you, you don't have to do both. Okay? If you're one that I just love using my calculator and I want to get to my calculator, it'll take a little bit of work to get there, but you can definitely do it. I think this is a little bit quicker, right? A little bit easier, I think. And the only bad thing is that you can't really use your calculator if you're going to do that method. So there's a lot of different options here, okay? Once again, this set of ordered pairs, or any ordered pair, but like I could take and plug it into this equation. 2 times 6 is 12, 12 minus 0 is 12. So I can take that ordered pair and just verify that it is an equation and satisfies that equation. So these first three that we did, these are all called linear equations. Okay, we're going to talk about a lot of different equations, a lot of different types of graphs as we go throughout the semester. But linear equations are any equation that makes a line. So it could have a positive slope, it could have a negative slope, it could be horizontal, it could be vertical. We'll talk about all of those more as we go throughout chapter 1. But these are all linear equations because they make a line. The second type of graph that we're going to do today is this one here, okay? And this is one we're going to see a lot more as we get later on in the semester. Today, all we're focused on is graphing it. We're not really talking about a lot of the specific things of it. But this is what we call a quadratic equation because it has an exponent of 2. And we can see a lot of different things. We could see equations that have an exponent of 2 or 3. We might see some absolute value later on where we have an absolute value sign that we have to graph. We'll see a lot of different types of equations. And so they're all going to be a little bit different. The shape that they're going to give us is a little bit different. But whenever I see an exponent of 2, what I want you guys to make sure you're starting to realize is, and we've seen this before, but a quadratic equation, you guys remember what kind of shape this graph's going to make? Anybody remember? What do you think, Zach? Yep. It's a good old U shape. Anybody remember what we call that U shape? Parabola. Yep. Okay. So it could be a U that opens up. It could be a U that opens down. Okay. And we've seen that before. But the reason I tell you that is because it's no longer a line. That exponent of 2 means we're not going to have a line anymore. So we got to be careful of that. So here's what I would do in this scenario. I'm going to plug in 0. And 0, 0 is a point. And I went ahead and just put 0, 0 here. But if I plug in 0 for x, 0 squared is 0. 0 times 2 is 0. So when I plug 0 in for x, it gives me 0. I could plug in 2. And I could start with 1, but I'm going to go just a little bit higher to get numbers to get the graph going up a little bit quicker here. So when I plug in 2 here, here's where you got to be really, really careful. And once again, you could put this right into your calculator, okay? And I don't have an issue with that, but just knowing where these numbers come from is really important. If I plug in 2 here, 2 squared is 4, because we got to do the order of operations first. And then 4 times 2 is 8. So as I start looking at this graph, we got 0, 0. We got 2, 8, but remember it's not going to make a line, so I want to plug in a negative number as well. And the reason why this makes that parabola is because now when I plug in a negative 2, I'm going to square the negative 2 first. And when I square -2, it becomes 4. And then 4 times 2 gives me the same y value. So I get 8 again. And it looks kind of weird, like, oh, I get the same number? You absolutely do get the same number here. Except we're going to go left 2, and we're going to go up 8. And then we can make our parabola, get our graph. Okay. And I know I keep coming back to this, but this would be something I could easily put right into my calculator, right? Okay, another one here. Once again, it's a quadratic. What's different on this one is we have a negative in front, okay? And the negative in front, and we've seen this before, it's going to take my parabola, the u, and it's going to flip it upside down. So it's going to be an upside down U shape. The 3 is going to make the graph move up 3. Okay, and those are all things that we're going to talk more and more about as the semester rolls along. So you don't necessarily need to know that, but those are things that we've talked about before, so you might be able to pull in that previous knowledge and say, oh yeah, I remember some of those things from past years. But here today, all we're doing is essentially just graphing. So I just need to get some points, I need to graph it, but you can use some of those things to kind of help you remember what the graph should look like as well. And one of the reasons why I tell you that, because last one, the U shape hit a 0, 0 and it came up, right? Here, the graph is going to go up 3. So I'm putting that vertex or that high point or low point in the middle of my table of values. And I want you to kind of generate a table of values when you do these. You don't have to have a ton of points, but just so I know these are the points that are on that graph. And you can do that from your calculator, you can do it on your own, but these are some points that are on the graph. So when I plot it, I'm plotting the actual graph that we have. So we're going to go up 3. And then once again, you can put whatever numbers you want in here. You could do 1 and -1. I'm going to go 2 and -2 again. So when I plug in 2, 2 squared is 4. And then I'm going to put a negative on it, which makes it -4. And -4 plus 3 would be -1. And when I plug in -2, -2 squared gets me back to 4. Negative times a negative makes a positive. You just got to be really careful about, like, when I plug this one in, you got to be really careful of your signs, right? So this one, I square it first, which I get 4, then I put a negative on it, and then I add 3, which is -1. So signs are really tricky. Sometimes if you were to write this out, a lot of people see those two negatives and they think, oh, that makes it positive. But you got to do the order of operations before you can apply the negative. So we got to do the exponent first. And so we have 2, -1. We go -2, -1. And once again, it's a U shape, but it's a U shape that's going down. Every time you see x squared, it'll be a U shape. If your graph doesn't make a U, that's the first red flag, like, hey, what's going on? Why is my graph not making a U shape? Okay. And once again, your calculator can be a great tool that you can use there. Okay, to finish up today, we're going to talk about some other parts of like a graph where we use some other formulas. We're going to see these formulas off and on, and these are all formulas, at least the first two are formulas that you've seen before. The first one is what we call the distance formula. If I were to give you ordered pairs of x1, y1, x2, y2. All that means is first x, first y, second x, second y. I have two ordered pairs. Ordered pairs are always x, y, and we're just labeling which one comes first, which one comes second. We take those four numbers, we're going to put it into the formula, and we're going to try to find the distance between 2 points that are on a graph. And that's kind of where it ties into what we've been doing, because we're putting points on a graph. The other formula that we're going to do today, and I'm going to put both of these on the same page here just because I'm going to use the same points, and we're going to talk about the difference between these two, is what we call the midpoint formula. And the answer is written differently for both of these. For distance, your answer is a length, like how long is the segment between those 2 points. For midpoint, we're trying to find the point that's right in the middle. And I'll kind of show you a visual here in just a second so we can kind of get an idea. But the midpoint formula is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Okay, so I'm going to give you two ordered pairs here. And it doesn't matter which one's first and which one's second. I can label this one x1, y1, and this one x2, y2, or they can be flip-flop. Really doesn't matter, okay? So I'm going to label this one x1, y1. I'm going to label this one x2, y2. And the first thing we're going to do is we're going to find our distance. But I want to show you, and you don't necessarily have to graph this, but just visually I want you to understand kind of what's going on here. So I'm going to graph this here. -2, -3 means we're going to move left 2, down 3. 4, 1 means we move right 4 and up 1. So those are our 2 points. And I'm going to connect those two together, and we're going to have a segment. Okay? And like I said, you're probably not going to need to graph this whenever you do this, because we're not going to really use the graph a whole lot here. We're using the formulas more than we're using the graph. But I want to show you what the answer represents here by looking at the graph. So on the distance formula, what we're trying to find out is how long this segment is, right? And we've done this several times before. It might have been all the way back in geometry since you've done this, but how long is that segment? Well, if my segment is horizontal, I can count. If my segment's vertical, I can count. 1, 2, 3, 4, 5. I can't do it when it's diagonal like this. I can't say 1, 2, 3, 4, 5, because I can't count diagonally, okay? It's kind of like saying how far is it from Bueller to Hutch, right? I can't, like when you say the direct distance would be a lot less than if I got to go down to Medora and down, or down to 30th and over. But the direct distance, we call that as the crow flies, then it'd be like the path that a plane would take or a bird would take to get from one direction to the other. They're not going to take a road to get there. So in this case here, we're going to plug the numbers in. So we're going to go x2 minus x1. And once again, we're going to be really careful of our signs here. 4 minus -2 squared. And then 1 minus -3 squared. And then when we subtract the negative, 4 minus -2 would really be 4 plus 2, which is 6. And then 6 squared would become 36. And then we have 1 minus -3, which is really 1 plus 3, which is 4. 4 squared would become 16. And that gives us radical 52. Well, radical 52 doesn't tell us a whole lot, right? If I said, what's the length of that segment, and you tell me radical 52, that doesn't give me a whole lot of information. Nobody really knows what that means if you say something's radical 52 inches long or feet long or something like that. So what would be better here is just to put that into our calculator, right? Take the square root of 52. And we get about 7.1, 7.2, something like that. I don't even know what the decimal would be. And we'll just label that units. U is what we use for units on a coordinate plane if we don't have a specific label. And so we're saying that this is about 7 units long. If I were to count, it's just a little bit over 7 units long. And that's what we're talking about when we do distance. When we do the midpoint, it's a completely different problem. But here I'm going to do it with the same 2 points just so you can kind of see the difference between the two. When I do the midpoint, I'm looking for the point that's right in the middle of this segment. And you can kind of eyeball about where it would be. I'm just kind of guess about where it's going to be here. But my midpoint is going to be between these 2 points. So we just want to find that middle point between the 2 points that we started with. Okay, once again, I'm going to use the same 2 points we had up here. I already have them labeled. So the first one, we're going to go -2 plus 4 divided by 2. And then we're going to go -3 plus 1 divided by 2. So then we just got to do order of operations again. -2 plus 4 would be 2. 2 divided by 2 would be 1. -3 plus 1 would be -2. -2 divided by 2 would be -1. So 1, -1 is the point. And it won't always be a nice whole number. It could be decimals, okay? Kind of like this one over here is a decimal. These could be decimals as well. So we don't just want to eyeball it and say, oh, it looks like it's going to be right in the middle at 1, -1. It could be a decimal, and then we wouldn't be able to just look at it and tell. But the big difference is this one is written as an ordered pair because we're talking about a point that's in the middle. This one is talking about a line. So my answer is just a number, a distance. You guys kind of remember those two from way back when? All right, the last one, and this is the one formula that you may not have done this one before. And I'm not going to go real in depth on this one. But it is one of those equations they want us to get exposed to, so we've seen it and done it. And we might have done this just a little bit in geometry or maybe scratched the surface of it, but maybe not a ton, and we may not have seen it at all. I can't. Some years we do this in geometry, some years we haven't. The equation of a circle, and I'm just going to put the generic form up here, is kind of a weird looking equation. And there's 2 things that I need from this equation. And if you think about a circle, there's 2 things that I would need to know about a circle. I need to know where its center is at. Where does it begin at? There's a point right in the middle of that circle that's equidistant from all sides, right? And then from that center, I could draw a radius out, and that would go to any point that lies on the circle. So that would be my second thing. And so here the R represents your radius. So if I were to draw a circle up here, this would be my center. This would be my H and K value. This would be my R value. And once again, this would be something that we could put onto a coordinate plane. My center is at 2, -3. My radius is 5. And then we could put that into a formula, and we could get an equation for it. And that's what this equation does. So if I were to give you -3, 4 is my center, and my radius is 5. Your center is your H and K value. Your radius is your R value. And we're just going to take those 3 pieces of information and we're going to put it into this equation. So we are not putting anything in for X and Y. X and Y just stay X and Y. The biggest thing you have to pay attention to here is this is a -3. So we're going to go x minus -3 because that's my h value. So when I do x minus -3, that really becomes x plus 3. And then we're going to do y minus 4 because 4 is my k value. And on the last part, my radius is 5, but we're going to square the radius, so this would be 25. Now, good news is that's how we leave it. That's our equation. We're done. The bad news would be is I can't like put this into my calculator. So if I asked you to graph it, you would go left 3, up 4, put a point, and then you would count 5 units in every direction to get to your circle if you had to. But that would be our equation. You just have to put in your h, k, and your r. And so that's one that's maybe just a little bit different. Okay, I think that's all we got for today. I'm going to put the assignment up here. Now, when I write this up, I'll just kind of give you a fair warning that I just kind of go through. There's 100 and some problems in all of these sections, right? And so rather than giving you like evens and odds, there's so many different things that are covered in these sections that I kind of just go through and pick out questions, and I kind of use the HCC assignments to help guide me. I don't necessarily assign the same questions or the same number of questions because I think they assign a little bit more than what I feel like needs to be assigned. So I kind of trim down the assignments a little bit from what they have assigned, but still at the same time, I want to hit all the key points. And so that's why when I give you this list of problems here, it looks like a lot of problems. But it's a whole lot better than giving you evens or odds, and then we get a wide range of stuff. So sometimes it'll be evens and odds, or we'll count by 3s or 4s or different things. It just kind of depends on the day.